Okay, good afternoon. So today I want to do sort of three things, and the first thing is we're just going to very quickly finish up this coastal oil drilling example that we were going through last time. Then I'm going to spend like maybe, I don't know, 4 or 5 minutes or so talking about one of the problem set problems. So if you're here today, then you're sort of in luck in the sense that you'll get to hear about this problem. If you're not, then you won't hear this. And then for the remainder of the class, we'll basically talk about how you actually go through and solve for equilibrium. So for an efficient equilibrium, and also for what may happen in a private equilibrium, even if it's not necessarily efficient. And I'll have you guys like sort of work a little bit in groups too on that, just to make sure that that you understand what it is we're actually saying. So the last thing that I wanted to say about this oil drilling example, so the scenario was essentially that like the state of California was thinking about whether or not to allow drilling offshore, and we sort of concluded two things. One is that whether you do so or not, it's not going to have a major effect on gas prices. So if the motivation is just because you want to lower prices at the pump, that's not going to that wouldn't ultimately be a very convincing reason. But on the other hand, if you do sort of a cost-benefit analysis, you can see that there are very large net private benefits in the sense that the state could generate a lot of revenue from an auction where it auctioned off those rights to an oil company, at least at current oil prices. And so then you basically have to come down to weighing the social cost of drilling against those potential benefits, and one would have to decide whether or not it was worthwhile from your own perspective. But the final thing that I want to note is that we said in the past, or we said in a previous lecture, that we have this thing called the Coase theorem, and the Coase theorem says that you can get to an efficient allocation or efficient outcome if you just assign property rights and then allow parties to bargain amongst each other. And in the example where we were initially discussing the Coase theorem, so we talked about like you could assign the rights to a refinery or you could assign the rights to a town that's affected by the pollution from that refinery. And in that particular example, I said that the ultimate amount of pollution that was generated wasn't affected by whether you assign the rights to the town or whether you assign the rights to the refinery. But then I kind of hinted that maybe in some cases that wouldn't always be true. So if the conditions for the Coase theorem hold, which admittedly is something elite because you have to worry about all these transaction costs and how you can, whether or not you can define the property right and measure the externality and so forth. But if the conditions for the Coase theorem hold, the theorem says that you will in fact reach an efficient outcome, but that doesn't mean that all efficient outcomes are the exact same outcome. Okay, and so in this particular case, this is a case where who you assign the property rights to is going to affect the final outcome or the final allocation of whether or not you end up drilling, most likely. So in this case, you can sort of think of two parties that you might assign the rights to. One would be the oil company, so say like ExxonMobil, and then the other would be maybe like a group of environmentalists like the Sierra Club or something, right? So if you assign the drilling rights to ExxonMobil, it's almost certain that the environmentalists would not be able to raise the amount of money that would be required to buy the rights from ExxonMobil and prevent drilling, because the numbers that we were talking about, like in the case where oil was $50 a barrel, we were estimating that maybe the rights would be worth like $200 billion. Oil is actually more expensive than that right now. I think it's closer to like $100 a barrel. So doing the math, I think it works out to something like $600 or $700 billion in terms of the total value of those rights. And it seems very unlikely that even in California, where we're very environmental and so maybe we donate to charitable causes involving the environment and so forth, it's very unlikely that the Sierra Club or anybody else would be able to raise like $500 billion to buy the rights and therefore be able to prevent drilling. So if you assign the rights to the oil company, then for sure there's going to be drilling. But on the other hand, I should also say there's like basically a free rider problem in that case. So even if somehow the willingness to pay of everybody who cares about the environment in California were $500 billion or however much it would take to buy the rights, that doesn't mean that the environmental group is going to be able to raise $500 billion, right? Because every person individually, you sort of come back to this free rider problem that you have with public goods. Every person individually might say, well, I really would prefer that they not drill, and I'm willing to put X dollars towards preventing that from happening. But you know that at the end of the day, since you have 38 million people in California or whatever our population is, your actual contribution will make no difference, just like your vote makes no difference. Which is not to say that you shouldn't vote on November 3rd or 4th or whenever our election is. But we do know that the probability that your vote is going to be the marginal vote that pushes one candidate over the other is very unlikely, particularly in California, where we know that Obama will carry the state with like 99.9% probability. That being said, so your individual vote or your individual donation isn't going to make a difference, and so the optimal strategy for you is to hope everybody else donates, but withhold your own donation, and that's like what we saw in the public goods game, right? Where all the groups were kind of hoping the other groups would donate, and at the end of the day, nobody donated. So even I think that sort of willingness to pay of people probably wouldn't be enough in that case to come up with that amount of money, and even if it were, you would still face this free rider problem. On the other hand, so if you assign the drilling rights to the Sierra Club, it's possible that the environmentalists might turn down the $500 billion from ExxonMobil. So when you assign the rights to ExxonMobil, there's going to be drilling, even if you can eliminate that free rider problem, just because the total willingness to pay is not enough to buy the rights back from the oil company. On the other hand, when you assign the rights to the Sierra Club, so basically what's going to happen then is ExxonMobil is going to approach the Sierra Club and be like, hey, you guys have the rights to prevent drilling. We would like to drill. It's worth a lot to us. We're willing to pay $500 billion to you if you relinquish those rights and give them to us. And how that would actually work out in practice, I do not know. So I think on the one hand, there's a good chance the Sierra Club would be like, no, that like kind of violates our entire charter and everything. So we can't just like, even for $500 billion, we can't just sell you the rights to go and drill. But on the other hand, if they were like pragmatic economists running it, maybe they'd be like, you know what, we don't like drilling, but $500 billion is a lot of money. And what we could do is basically allow drilling off the coast of California, which admittedly has substantial environmental costs. But with that $500 billion of money that we get, maybe they're able to like buy up half the Amazon rainforest or something and prevent mass deforestation. And so then it's sort of like, well, we really don't like drilling, but we like the idea of losing all the rainforest even less. And so maybe we'd be willing to make that trade-off. So there's some state of the world maybe in which the final outcome would be the same, which is that you drill regardless. But I think there's also probably a good chance that if you give it to the Sierra Club, they basically are unwilling to sell it at any price. And so then ExxonMobil would not be able to buy the rights and wouldn't be able to drill. So you could get a different outcome depending on who you assign the rights to, but that's not to say that isn't, in this particular case, that's not implying that the Coase theorem is necessarily failing. It's basically just implying that when you assign lots and lots of something that's worth a ton of money to the environmentalists, then the environmentalists basically have the financial ability to have their preferences be expressed in dollar terms in a very large amount. And so then in that case, the efficient outcome is to not drill. On the other hand, when you assign something that's worth a ton of money to the oil company, then the environmentalists don't, obviously don't want the drilling to occur, but they basically don't have enough money to prevent it from occurring. And in that case, then the drilling occurs. Either way, it's an efficient outcome from the perspective of our definition of efficiency. Now that it's, I think on the one hand that shows that our definition of efficiency is kind of a subtle concept. On the other hand, it also kind of shows the limits of that definition, because basically what it doesn't take into account is what we call like distributional considerations, right? Like in the one case where you assign the right to the environmentalists, then the environmentalists end up happier, and in the case where you assign the right to ExxonMobil, then ExxonMobil ends up being happier, and the reason is because you're assigning something that's incredibly valuable. So you always want to be the one who receives something this asset that's really valuable. We don't, as economists, like we don't really have anything to say about that. It's sort of more in the realm of like public opinion and public policy, and it's up to sort of the country as a whole to decide which groups it wants to advantage and which groups it wants to disadvantage. But all we can say is that in the case where you have assigned a lot of purchasing power to the environmentalists, then it may well be the case it's sufficient for them to express their preferences by not allowing drilling. And in the case where they can't afford to stop the drilling, then it's sufficient to just let the drilling go ahead. Okay, so that's what that's an example of a case in which the Coase theorem can hold, but you can still get different outcomes. Now, let's see. Okay, so the other thing that I want to talk about, I realize, is this last problem on the problem set. So if you haven't taken a look at this yet, then you will.
Is there a number 6?
No, that's there will be a number 6, but it's like the first question on the next problem set. So the last problem is in fact number 5. Here, I'll scroll up a little bit so there's nobody has to get nervous about that. Number 6, you technically, I mean, you guys, many of you might already know how to solve problem number 6, but we haven't technically gone over that yet, and that's what we're going to go over today. Okay, but number 5 says, so these are all true-false questions. Let me just be very explicit about this. That both on the problem sets and the exams, the true-false questions are going to be the hardest questions. There's no, almost everybody's going to find that to be the case. And the reason is partially because there's some ambiguity in them, and that's just kind of a fact of life. That's why there's multiple questions. So even if you kind of make an error on one of them because you don't quite get exactly what the question is asking, then you can make it up on another question. But question number 5, actually, I think we didn't really talk about all that much in the lecture. So I'm going to basically, I'm essentially going to give you the answer to number 5, but the answer is going to be, but if you try to just, so you could try to copy down everything that I'm saying, but that would probably end up being like a page long, and in reality, you need to answer it in a short paragraph, like 5 sentences or something. So really, the key is to understand what it is I'm saying, and then just be able to briefly summarize that. So the question itself says, a disadvantage of the revealed preferences approach for valuing a non-market good as compared to the stated preferences approach is that the researcher has much less control over how the non-market good is assigned when using the revealed preferences approach. So there's sort of, I think, probably about 4 key things here in this statement. So 2 of the key things are obviously revealed preferences and stated preferences. So the revealed preferences approach we went over, it's basically looking at how much people are willing to pay for particular goods that have some sort of public good or environmental amenity or some other non-market good associated with them, and then using the observed willingness to pay for those goods that have the environmental good or the non-market good bundled with them to figure out how much people are willing to pay for that non-market good. The stated preferences approach you guys actually did, where we did the survey, and I just asked you how much would you be willing to have this increase in safety, or how much would you be willing to prevent oil drilling or something like that. So those are the 2 approaches that are being compared. The other sort of 2 keys here are, first of all, the non-market good. So that's the good that we're trying to value, of course. So it's going to be something like a reduction in risk, or preventing oil drilling, or cleaner air, or some other good that people care about and value, but that isn't actually traded openly on a market. And so that's the thing that you're trying to value. And then the last thing that's key here is the assignment. So that's what we didn't really talk quite so much about in the lecture. So in the lectures, we talked about the revealed preferences approach. And I gave you this example with the housing market and valuing public schools. We also talked about the stated preferences approach, and I basically gave you all of these potential biases that can creep in, like the framing bias and the strategic bias, and those biases are basically a reason why we prefer not to do the stated preferences approach when we can avoid it. But I didn't really talk that much about the limitations of the revealed preferences approach. And the limitation is essentially that you don't. So the nice thing about the stated preferences approach is you can design any sort of scenario that you want, right? So even something like how much would you pay to prevent global warming, you can just ask that in a stated preferences approach. It's very hard to do that in the revealed preferences approach because there's no good that's transacted on the market that somehow involves living on a globally warm planet versus living on the normal planet with a stable planet, right? So you can't kind of observe a market transaction where global warming is sort of bundled in with that transaction somehow. So there's kind of 2 problems. One is what I just said, and that also, I said that in the lecture originally, which is that in some cases there's just nothing, there's just no good at all that's being transacted on the market that has this non-market good bundled with it. But the other case, which is a bit more subtle, is that sometimes the non-market good is bundled with a market good, but you can't isolate exactly how. So you can't isolate that non-market good from other attributes of the good. So I'm just going to give a couple examples so that you can hopefully understand what it is that they were trying to convey here. So one example would be the housing example that we did, where we're trying to estimate the effect or estimate people's willingness to pay for better public schools. So certainly, because of the way that public school systems work, the public school district is in fact bundled in with housing transactions, so you can potentially use housing market data to figure out how much people are willing to pay for a better public school. The problem is that potentially there could be other things that are valuable about houses that may also be sort of correlated with the public school system, right? So I gave you this specific example where we're probably able to isolate or sort of eliminate these other things because we compared 2 houses that were right on the boundary of the school district dividing line. And so typically you'd be well, I know that the school system in Orinda, which is over the hills over there, is better than the school system in, say, West Oakland. But it's also the case that West Oakland is right next to an industrial port, which is also probably undesirable from a housing value standpoint. And Orinda is a clean, safe suburb and so forth, right? And so if you try to do a comparison between Orinda houses and West Oakland houses to figure out the value of the school system, part of that difference that you observe in the housing prices would pick up the value of the school system, but it's also the case to be picking up the value of not living near a major port and the value of having a lower crime rate and so forth. And so the problem is that you, the researcher, aren't able to kind of manipulate or assign exactly which houses have good school systems and which don't, right? Because if you could, then you could basically run your own experiment. It becomes being a natural scientist or something where you go and you want to measure how exposure to microwave radiation affects fruit flies or something. So you just get a bunch of fruit flies, and some of them you're going to expose to microwave radiation, and some of them you won't, and you randomly select which fruit flies are exposed to the radiation and which aren't, and that's going to ensure that the only thing on average that's different between those 2 groups of exposed and non-exposed flies is the radiation assignment. My understanding from comic books also is that the fruit flies would then become superpowered and take over the university, but that's kind of a different story. So that's sort of one example where potentially you would like to be able to actually manipulate or assign the non-market good, which in this case is the schooling system, to the houses, but you can't. You just have what we call observational data. They're just as given. You don't have control over who got the good schools and who didn't. So there might be other factors that are correlated with being in a good school district. Okay?
So, the example that you just gave, are you saying that the precision codes are parameters not going to be accurate enough, or are you saying that it's biased?
So the example that I gave, comparing West Oakland and Berkeley, I'm saying that's going to be biased. So the idea is, so precision is mainly a function of. So the precision of an estimate is going to be mainly a function of how many data points you have. But in this case, even if you could collect like data on hundreds and hundreds of thousands of housing transactions, both in West Oakland and in Berkeley, it would still be the case that you would observe a big difference between in values in like home prices between those two areas, and it would still be the case you wouldn't know how much of that difference was because of the good school districts and how much was because you're not living next to a major port. And so like the way to think of it is, even with an infinite amount of data, that inference problem still would not be solved. So it's a bias problem.
The public school effect is not correlated with anything that we built in there.
Mm-hmm.
Like that's still not going to be, like it's not, still not going to affect the parameter average. Or
Well, so the public, when you say the public school effect, it wouldn't be the effect that's correlated with it. It would be the value or the quality of the public schools that would be correlated with it, right? Like, so Orinda has better public schools, and it also is not next to a port, right? But the effect is basically just a number, like it increases your property values by $100,000, and so you can think of that as like a constant rather than some sort of variable that might be correlated with other variables. So that's one example. Another example, which I think maybe comes up in the problem sets or something, I forget, but is so like you did the survey where I was asking about willingness to pay for like an airbag that would help protect you in the case of an accident. So that survey or that question is like it's not entirely random. I mean, there are actual papers out there that look at people's willingness to pay for automobile safety features and then try to infer from that how much people are willing to pay to reduce the risk of a serious injury or fatality. And if you can, so you can sort of imagine that like if you had two cars that were exactly the same and one of them had the safety feature and the other didn't, and consumers knew this and they understood sort of what the risks were with and without the safety feature, then you would actually be getting a pretty good estimate of people's willingness to pay to decrease the risk of dying by however, whatever small probability it is. But in a lot of real world situations, that's not exactly what you have, right? So you have it be the case that like there's multiple trim lines of a model. So like maybe you look at the Honda Civic or something, and if you buy the most expensive trim line of the Honda Civic, then it has like traction control and it has like 9 side airbags and so forth. And if you buy the least expensive trim line, then it doesn't have those things. And so you're getting the difference in safety features, which maps into a difference in risk that you want. But it's also the case that the most expensive one has like leather seats and some 500-watt sound system and whatever else bundled in with it. People are also, of course, willing to pay for those additional features, but you're not trying to measure the value of like a sound system, right? You're trying to measure the value of the safety features. And so in that case, again, you're going to have a problem where you observe the difference in price between these two models, and some of that difference is due to the safety features, but some of it is due to these other attributes like the sound system and so forth. And so what you'd like to again be able to do is control like which models are getting the safety features and which aren't, so you can sort of come up with an experiment where you have two models that are exactly the same except one has the safety features and one doesn't. But again, since you're using the real preferences approach, you don't have that ability to manipulate or assign the good in question. Okay, so that's basically how you should be thinking about the last question.
Okay, so the statement preferences, they also advise you as well, but here that you say that the contingent valuations, as far as so are we basically kind of going off of which one has lived?
Yeah. Right. Sure. Sure. No, that's absolutely true. And that's a good question. So they both have biases, and they're sort of different types of biases. And it will kind of come down to like a case-by-case decision as to which one you would want to use, right? So like in the housing market case, in like value public schools, the example that I gave there, we were able to come up with like a pretty good, we call it a natural experiment, like sort of a pretty good natural experiment where we come up with like two sets of houses that were actually really close to each other and very similar on many dimensions, but one has the good public schools and one doesn't. So in that kind of case, you probably want to go towards using the reveal preferences. But you can also get into situations where either the good is just the non-market good is so highly correlated with other attributes of the good that people are also willing to pay for that it's impossible to figure out like how much of the additional willingness to pay is from say the safety benefit and how much is from all of these other differences about the cars we were talking about. So you could end up in those situations, or you could end up in the extreme situations where there's just no market transaction that sort of has the good that you're interested in measuring bundled into it. So like preventing drilling in the Arctic National Wildlife Refuge is not something that really would be reflected in any market transactions that we observe. And so in those cases, then you basically have almost no choice but to go towards like stated preferences. So it's going to be a case-by-case decision. I think the tendency is to go towards reveal preferences methods when they're available, but if there's really serious bias or they're just not available, then you have to go towards stated preferences. Okay. Oh, sorry.
Sorry, could you clarify one last time about what you meant by assigning denominator?
So I mean, I would just put it as like you would like to be able to manipulate which products have that non-market good assigned to it, be it like a good public school or increased safety or something else like clean air or something like that. As a researcher, you would like to be able to manipulate which goods are getting that and which aren't, so that you can basically design an experiment where you hold other factors constant but just manipulate that good, like whether or not you have that good. Okay, so then the last thing that we'll talk about today is solving for equilibriums and efficient allocations. So we spent like a lot of time talking about how you get how you can get an efficient allocation or an efficient level of production. And so we said, if there are no externalities and sort of other things like perfect information and no transaction costs and so forth, then you can just kind of have free trade or just have like a market system that will get you to an efficient outcome. But if there's externalities and so forth, then we need to start thinking about corrective fees and taxes. But we haven't really talked so sort of explicitly or in practical terms about how you would determine, first of all, what levels of consumption or production the consumers and firms are going to choose. Second of all, what level of consumption or production that you want the consumers and firms to choose. And those are the two questions that I'm going to just go over in the last 20 minutes here. So if you've taken previous econ courses, which you are supposed to have, so I assume you have, you probably are aware that most economic problems involve either maximizing